Hello geometry students, and welcome to a video that's a continuation of lesson 6-3 on translations in coordinate geometry. So we're to the point where we've already done a few translations, and we've done one example where we did both a reflection and a translation. And so just to remind you of what we did for that example, because this video is just going to be about two more examples similar to this, is we first took the pre-image, we graphed the pre-image, which is this blue one. First we reflected it over the x-axis, what you're looking at right here. Then we took this image, which is the reflection over the x-axis, and we translated it according to the rule going over 9 and up 2. So it went over 9 and up 2. Okay, so we're going to do that again with two more examples, and that's what we're going to cover right here. So let's first refresh our memory on how we are going to reflect over the line y equals x. And just a quick reminder on how to know where to start here is to take a look at the previous notes from Friday, which is actually lesson, here it is, lesson 5-2. That's from last week. And sorry, it's not from Friday, it's from, well, it is from Friday, but we were going to do it on Wednesday. Okay, so here's the rule for reflecting over the x-axis, the rule for reflecting over the y-axis, and then on page 2, we came up with the rule for reflecting over the line y equals x and y equals negative x. So I'm going to refer to these in example 10 here when we first reflect over y equals x, and then 11, number 11, where we reflect over, again, the y-axis again. All right, so first, that line y equals x. Let's just get that in front of us so we know what we're going to do here, because we're going to start by reflecting over it. So I'm going to graph the line y equals x, which just goes from corner to corner and through the origin. So I just go from corner to corner, something like that. And so there's the line of symmetry that we're talking about for this problem. All right, that's the line y equals x. Now I'm going to graph the original triangle that's given. Actually, sorry, it's the parallelogram, so I'm going to graph that. So 2, negative 1, there. That's our Q. 7, 1 is here. 7, 1. 6, negative 2 is here. And 1, negative 4. 1, negative 4. And sometimes, when I'm looking at these, I'm thinking, like, how is this going to make a parallelogram? But it does look like it did. So down 1, 2, 3, and over 1, down 1, 2, 3, and over 1. Yeah, it's going to be a parallelogram. So I'm going to connect this, and this is my pre-image. So after I connect it, I'm going to shade it blue, because I like to shade all pre-images blue, just so we have something to sort of get used to. Okay, so there's the pre-image. And now we're going to do the first step, which is I'm only going to graph this as a dotted line. I'm going to find the coordinates, but I'm going to graph them as a dotted line. So in my middle step here, I'm going to I just switch x and y. Remember how you do that. So when you reflect over the line y equals x, you just switch x and y. So let me just plot my points here. 2, negative 1, this is my Q. 7, 1, that's my R. 6, negative 2 is right here, and that's my S. And then T is 1, negative 4, which is right there. Okay, so I'm just going to take each of those coordinates and switch them around. So Q will become negative 1, 2. Negative 1 and up 2 right there. There's what would be Q prime if we were going to be done. R would be 1, 7. So 1 and then up 7 is right there. Remember, these grids all have 8 units, so you don't really have to count. Negative 6. Oh, sorry, 6, negative 2 will become negative 2, 6. So negative 2 and then up 6 is right there. And then 1, 4 would become negative 4, 1. So 1, 2, 3, 4, and then up 1 right there. And now this is going to be my middle step. So this is not my final image. It is the image of this pre-image, but it's going to be the pre-image of this translation. So now let's just take a note of what these points were. And I'm going to do it by looking up here. So this is the point, let's see, this was the negative 1, 2 is right here. This is negative 1, 2. And then 1, 7 is right here. 1, 7. And then 6, negative 2, so negative 2, 6 is right here. and then negative 4, 1 is right here. Okay, so now we're going to take these and we're going to apply this rule. So I'm going to squeeze them in right here. I'm going to squeeze those coordinates in, kind of write them a little bit small, because this is kind of where they would go. I would like them to go. So we have these points that I just said. So the Q is negative 1, 2. The R is 1, 7. The S is negative 2, 6. And the T is negative 4, 1. And again, I know I'm reading all these backwards. I'm reading every point up here backwards because that's what the reflection over the line y equals x did. It switches the coordinates. Now I'm going to apply the rule that I'm given, which is x, y goes to x minus 3, y minus 7. Okay, I'm going to apply it to those points that I just found doing the reflection. So what do we get? We get negative 1 minus 3, that's negative 4. 2 minus 7 is negative 5. 1 minus 3 is negative 2. 7 minus 7, that's 0. Negative 2 minus 3 is negative 5. And 6 minus 7 is negative 1. And negative 4 minus 3, that's negative 7. And 1 minus 7 is negative 6. Okay, now we're going to plot those points, and that's going to be our final image after both reflection and translation. So let's see, we have negative 4, negative 5 is 1, 2, 3, 4, 1, 2, 3, 4, 5 right there. That's going to be my Q prime. Let's see where some other points are before we continue. So we have negative 2, 0 right there. We have negative 5, negative 1, so negative 5, negative 1 right there. And then we have negative 7, negative 6 right there. Okay, and this is my T prime. This one, let's see if I can just backtrack here. So Q prime was here, negative 4, negative 5. This one is Q prime. Now that I can see where the parallelogram is, I'm not going to be writing it where the lines are. Negative 2, 0 is my R prime. And the other one must be S prime. Alright, let's connect them, shaded green, and we'll be done. Hopefully this looks like the same parallelogram. They always should look the same. As long as all that we're doing is reflecting, translating, eventually rotating, as long as that's all we're doing, we should never be changing the shape of the figure. So what I mean by that, never changing the shape of the figure, means that if I were to take some tracing paper, and I had some here, okay, so I found a piece of tracing paper, and if I were to trace the figure on the tracing paper, and it doesn't have to be perfect, you just want to make sure you get those vertices perfect, but I'm still going to put the points, then I should be able to put this right over so that T goes right over T prime, so it's going to be something like that. No, it's going to probably be reflected something like this. There we go. And see how it's the same shape, and see even though it's you know, the letters change their orientation, but there's still the S's, and that's still the R and the R prime, and that's still the Q and the Q prime. And you see how the image is, the parallelogram is really the same shape and size. That's what's always going to happen unless we're doing a dilation. You're not going to change the shape or the size of the figure. And I recommend getting some kind of, when you get your ruler, if you haven't already gotten it, get some very thin paper or some tracing paper. All right, this one I'm just going to set it up, and then we're going to just talk about the important part. So I'm going to first sketch the pre-image, and then I'm going to apply the translation, and then we'll go from there. So you guys, let's pause the video and work on that together. Okay, so let's see if you guys have the same thing. So there's the pre-image graphed, and there's the image after this translation. So what I did was I just wrote underneath the points negative 2, 7, and what I did was I just added 6 to negative 2 to get 4. I subtracted 8 from 7 to get negative 1, and I did that to get these 3 points as well. And then there's my middle image. Now I want to take these points, so I'm going to take my 4, negative 1, my 8, negative 5, 6, -7, and 2, -3, and I'm going to apply the reflection over the y-axis. Reflection over the y-axis, just as a reminder, here's the rule. It takes xy and it switches it to -xy. So our rule will take xy, which we now have a bunch of, right? We did the translation, and it's going to go to -xy. Okay, so we can just see the points here. If this was 4, -1, this would be -4, -1. This would be -8, -5. This would be -6, and this would be -2, and the y's don't change. So -6, -7, -2, -3, and let's go ahead and plot those points. That will be the final image. Let's show, that's always nice to highlight the line when you're reflecting. So this is our reflecting line right there. So it's going to reflect over that line when we apply the rule that we already applied right there. Okay, so let's go ahead and reflect it and see if we get the same final answer. Okay, there you go. There's the final image. These points at the vertices are just the same as the points that we found here. Just to review, first we applied the translation. When we applied the translation to the 4 pre-image points, we got these penciled in points here. I wrote them here because once we did the translation, we're going to do a reflection over the y-axis. We looked up how to do that and realized that's the rule xy goes to -xy. So I applied that rule to all 4 of these points. I plotted these points, and I got the final image, which of course is identical to the original image, only it has now been moved and flipped over that axis. Okay? I hope you found this video helpful.